You've seen them, right? Scurrying in the corner of your room. Maybe you swat them away without a second thought. But what if I told you that little spider is one of the most bizarre, ancient, and honestly, over-engineered creatures on this entire planet? And this quote, yeah, it just nails it. A spider looks simple, right? But once you actually start digging in, everything changes. We think we know what they are, but the truth is, it's way stranger than you can imagine. So let's peel back the layers on this creature that's been hiding some absolutely incredible secrets right there in plain sight.
Okay, so first things first, we have to get the biggest misconception out of the way right now. Spiders are not insects. I mean, not even close. You can see it right here. They've got 8 legs, not 6, 2 body parts instead of 3, and nope, no antennae. They belong to a totally different and way, way older branch on the tree of life.
And when I say older, I'm not kidding. I mean ancient. Their story starts long, long before the world we know even began to take shape.
Just look at this timeline. It really puts the sheer scale of it all into perspective. Spiders, they were crawling on land 400 million years ago. Think about that. That's before the first dinosaurs walked the earth, before most trees existed, way before the first flower bloomed. They were some of the very first complex predators to actually leave the ocean and make it on land. I mean, they were true pioneers exploring a world that was pretty much barren and alien.
And their family tree? Well, it's just as surprising. You might think their closest relatives are bugs like beetles or bees, but nope, it's scorpions, ticks, and get this, even the horseshoe crab, you know, that living fossil from the ocean? They're all part of this super ancient group called chelicerates, basically survivors from a completely different version of planet Earth.
So how did these ancient pioneers become such ridiculously dominant predators? Well, they came up with 2 revolutionary inventions. Let's kick things off with their chemical weapon, venom.
Now, when you think of spider venom, you probably think its main purpose is for killing, right? You know, a quick way to take down its next meal. But believe it or not, that's not where the story started at all. The wild thing is, venom actually started as a way to eat. It began as simple digestive enzymes, basically juices produced near the fangs. See, spiders are external digesters, which is kind of gross but cool. They inject these enzymes to basically, well, liquefy their prey's insides before they eat it. It was only much, much later that some of these digestive enzymes mutated and became the potent, paralyzing neurotoxins we're familiar with today. So the key thing to remember is, digestion came first, death came second.
All right, so if venom was the spider's weapon, then silk, well, silk was its superpower. And I'm not exaggerating when I say we're talking about one of the most incredible materials in the entire natural world.
To really get how amazing this stuff is, just look at this comparison. Pound for pound, spider silk is actually stronger than steel. But here's the kicker, it's not brittle. It can stretch up to 40% of its own length without snapping. We as humans have not managed to create any material that even comes close to that combination of strength and elasticity. It's just mind-blowing.
But just like with venom, silk didn't start out being used for what we know it for today, webs. For millions and millions of years, the original purpose for silk was just to create little protective cocoons for their eggs. That's it. Then later, they started using it for safety lines, drag lines, and to line their burrows. That iconic, beautiful aerial web, that was a relatively recent invention in the spider's history. It was just the final brilliant step in turning a simple protective fiber into a high-tech, deadly trap.
Okay, but this is where things get truly, truly wild. The web is so much more than just a sticky trap. In a very real way, it's an extension of the spider's mind.
So, is a web just a passive, sticky net waiting for some poor bug to blunder into it? The answer is a hard no. The reality is way more active and, frankly, far more incredible than that.
You have to think of the web as a giant sensory organ. Every single strand is tuned like a guitar string, and it transmits vibrations with stunning clarity. A spider sitting in the center can literally feel the difference between a trapped beetle and a falling leaf. It can tell what kind of prey is struggling just by the frequency of the vibrations, and it can estimate its size by the amplitude. The web is a physical extension of its nervous system. It lets the spider see its world, but with vibrations. It's its cognition made out of silk. So if the web is basically a part of its mind, then the spider's body, man, that's something else entirely. It's packed with features that seem almost alien in their design.
Let's just run through a few quick examples here. Some jumping spiders have telescopic retinas. I mean, they can literally move parts of their eyes inside their head to scan and zoom in on things. And their legs, they're hydraulic. They don't use muscles to extend their legs like we do. They pump blood into them to push them out, which is what gives them those insane, powerful jumps. It's also why they curl up when they die. The pressure is gone. And on top of that, a lot of spiders are covered in these special hairs that are so sensitive, they can basically hear by feeling sound waves vibrate through the air. It's just wild. So you add it all up, the high-tech venom, the super material silk, this totally alien body, and you get a creature that is just incredibly effective. But does that make it smart? Does that equal intelligence? Especially when you remember its brain is about the size of a poppy seed. Well, let me introduce you to the Porsche jumping spider. This little guy does something that is just unbelievable. When it hunts other spiders, which are often bigger and more dangerous than it is, it doesn't just rush in. No, it will sit and watch its target for hours, analyzing the structure of the other spider's web. And then it will plan and execute a complex, roundabout detour to attack from a total blind spot. This isn't just simple instinct. This points to actual planning, spatial memory, and maybe even forethought. So how on earth is this possible with a brain that small? The answer might lie in a fascinating concept called embodied cognition. The basic idea is that thinking isn't something that's only locked away inside the brain. Instead, intelligence is distributed across the entire body and its sensory systems. The web acts like an external hard drive, processing all that vibration data. The hydraulic legs are giving constant feedback on pressure and position. Those tiny hairs are building a 360-degree sensory map of the world. The spider isn't just thinking with its brain, it's thinking with its entire being. And that really leaves us with this one big final thought. The spider completely challenges our whole definition of what intelligence even is. It's living proof that you don't need a big, complex brain to have complex, planned-out behavior. Here we have a 400-million-year-old survivor that forces us to ask a really profound question. What other forms of intelligence, what other kinds of thinking might exist all around us, maybe even right under our noses?